This is Food Chemistry Unit 2, Chapter 5, Energy, Matter, and Motion. Any change that occurs in the universe requires energy. Cooking food, digestion, driving a car, watching TV, etc. Energy is defined as the ability to do work, so particularly in food science, a force, energy, is needed to change the position, shape, or structure of food. Energy is needed to process, preserve, and package food. Energy affects the structure of food during these processes, which also involves heat that is transferred. Potential energy is stored energy or energy of position. An example would be this apple on the table. It has potential energy in the form of carbohydrates. That energy hasn't been used yet. It's still in the apple, right? It has been eaten, so this is potential energy. Kinetic energy is energy of motion. So an apple that is eaten releases the potential energy in your body where it is now kinetic because it's moving to where it is needed in the body. External energy is energy applied by another source. Someone heats up water for pasta. That water is given energy by the heat source. Internal energy is energy contained within a system. You have fat in your body. That is your internal potential energy. Then you have molecules in the body that are constantly moving and working. That is your internal kinetic energy. Energy can change forms. So mechanical energy is your total kinetic and potential energy of a system. So the human body, for example, has energy that can be stored or potential or used to run your body. This is kinetic. It's based on the food you eat and the amount of exercise you complete. Chemical energy. Forming and breaking bonds during chemical reactions like digestion, for example, keeps us warm, helps us move, and allows us to grow. So forming and breaking, right, during chemical reactions. Endothermic. Endo means within and thermic means heat. This is a reaction that absorbs heat or stores energy. Homemade ice cream, right? You add salt to ice and that lowers the temperature of the water. It drops the freezing point, so that ice now feels colder. This is heat that was absorbed by the salt and the water, so it feels colder and allows you to make homemade ice cream. Exothermic. Exo means outside, thermal means heat. Two examples here. You have drain cleaner. This is sodium hydroxide or lye. When you add it to water, that reaction releases heat. Hopefully that heat melts the fats and breaks up the clog, and yay, your drain is clear, but I don't know. I guess it depends on the nature of the clog, but that's the basic idea. Heat from that reaction of lye or sodium hydroxide and water melts the fats and breaks up the clog. Digestion. Food is broken down in your body, and this is released as heat, and the body uses that heat to stay warm. Now, metabolism. These are your physical and chemical reactions constantly occurring in your cells. Your body needs energy for all of its functions, breathing, moving blood throughout the body, building new tissues, etc. Some reactions break down molecules to release energy. Some reactions use energy to produce new molecules. This occurs in the cytoplasm of the cell. This is this gel-like material, right? With fluids and particles needed for metabolic reactions. Normal metabolism helps keep homeostasis. And homeostasis requires oxygen and ideal body temperature, and this is really what it means. It's a balance, right, of substances in your cells. So it's your body's internal balance. Now, what influences the rate at which processes of metabolism occur? This is not set in stone, right? I believe it depends on each, individual. But here are just some general influences on metabolism. Age. Metabolism is usually higher when you're younger. Your body temperature, if you have a fever, that tends to increase the metabolism, right? You have a foreign entity that's causing that body temperature to go up. So your body's going to respond with a faster metabolism. Height, it's often higher in taller people because there's more of you, right? So there's more reactions that have to occur, and that tends to increase the rate. Your level of physical activity will increase the rate because there's more energy to be burned. If you have more muscle, there's more active tissue, so the rate increases. And in general, your energy supply. Fasting tends to lower the rate, so you're often asked to fast like before a blood test or like a surgery, something like that. Your body will conserve energy. It breaks down fat and protein once that energy is depleted. Electrical energy is produced by movement of electrons, right? That's a subatomic particle. It's the negatively charged particle. Good conductors transport electrical energy, such as metals. Appliances will convert that electrical energy into light, heat, or mechanical energy, like blending, mixing, things like that. Radiant energy is energy transmitted in the form of waves through space or another medium. And this might look familiar to you. This is the electromagnetic spectrum. It shows you all the different types of radiant energy. We'll focus on 3 of these: visible light, IR is infrared, like buffet lights, and microwaves. These are all types of radiant energy that food scientists use. All right, so let's look at microwaves, right? These convert electrical energy into radiant energy to cook food. Inside the microwave is a magnetron. This is an electron tube. It's the source of energy for this oven. It converts electrical energy into microwaves. These are low frequency, so they're on the relatively safer end of that electromagnetic spectrum. So they're low frequency electromagnetic waves of radiant energy. Microwaves travel in straight lines. They're reflected by metals. That's why you don't put metals into a microwave, but pass through glass, paper, and plastic. So those are your general categories of types of containers that you can put into a microwave: glass and paper, and that actually does depend on the type of plastic. Now, if you have more water in your food, the faster it will cook. Water molecules are agitated by the energy, and that kinetic energy increases, right, and heats the food. So really the microwaves are searching for the water in your food. The more water you have, the more agitation, the more heat that goes into the food. Liquids and foods with a lot of water heat the fastest in a microwave. It helps conduct heat from other compounds in the food. So drier foods can be heated up in the microwave, but really the microwaves are looking for the water. And this is a great little video that shows you the general concept of the microwave. So there's the magnetron, which you probably don't see. You might see the outside of it on the inside, but in general, you don't see that. Okay. All right. Now this is the type of cooktop we will use. It's called an induction cooktop. So it uses electromagnetic waves to generate heat in food. Special metal pans are required for this. There are alternating currents that create a magnetic field that moves electrons and produces a low electric current. Why we use this: it reduces cook time, and the cooktop does not remain as hot. It also uses less energy.